Hello there. Welcome to the channel. My name is Matt Kostovec, CEO and co-founder of DataForge. And at DataForge, we look to automate the tedious and simplify the complex, specifically within the data engineering world, and how to build and manage large-scale data platforms, build them out iteratively and add to them even when there are thousands and thousands of pipelines or code that must be added to or managed over time. One of the most common challenges we run into is an incoming customer or a solution that is built on legacy technologies, has thousands and thousands of lines of code that are currently in production and the business relies on. However, for various reasons, they look to modernize their stack, work with some of the newer technologies, and take advantage of new frameworks like DataForge that can help them manage these large complex solutions over time and at scale. So rather than talking about theory, about all the ways that DataForge can help, let's look at a real example using some real customer code and highlight how rethinking or reimagining how to build data platforms using the DataForge framework can have a massive impact on the overall complexity and simplicity of operations of a modern data platform. So let's jump in. Look at the case study and the example that we ran into when working with this specific customer. So the existing solution was a data warehouse built on premise on Oracle, originally built by with help from a technology called Warescape. It's a data warehouse automation tool, really great at generating SQL scripts on the native technology. But focused on, again, this sequential stage-based approach. We'll get in more into the architecture of the original solution in a few slides. But let's focus on why the customer wanted to move to a new solution and their key metrics for success. They were focused on supporting ML and AI, migrating to cloud infrastructure. They actually had a large Oracle licensing obligation that they were hoping to reduce and optimize for overall cloud spend or overall IT spend. On licensing, they're hoping to reduce operational overhead. This was focused on the day-to-day break fix. They had a very complex, very large solution that when it broke, it took a long time to figure out how it broke and how to resolve those issues. And lastly, they had big aspirations to expand. So today, it was mostly on a single system, a single ERP. They had a few reference files via Excel. But they were hoping to add 3 or 4 additional systems to this, some mergers that they did and acquisitions that they did, as well as third-party data sources to help them augment and feed in those ML and AI capabilities, supporting new use cases and new ways to leverage data and analytics within their organization. Let's now take a look at the metrics around the existing platform to show the immense sense of scale and how big the problem was that they saw they're facing. Their actual target tables were relatively few in the grand scheme of things versus what we've run into elsewhere. They had 31 target tables. Around 16 of them were in a traditional data warehouse model for Kimball, star schema, for those of you familiar with that. And they had 15 other miscellaneous. Some of these were more operational, the history of certain things over time, and other very specific data sets outside of the data warehouse model. What was surprising to us and pretty amazing is the number of scripts and the number of lines of code that were developed over the course of about a decade of leveraging this platform that ultimately supported these target tables. They had almost 5,000 SQL scripts. They had almost 500,000 lines of code that they then were looking to replace with a more modern stack, with a more modern solution. Whenever they looked at evaluating how to do this, it was viewed as generally impractical. If you think about, just how quickly can someone write all that code to migrate this by hand without some type of automation. And this was really their approach, was looking at the existing solution and how can they take that code base and transfer it to a more modern code base solution, a different set of technologies, while implementing the exact same logic, while supporting the same 31 tables, and also setting up a foundation for them to expand into the future. Just a few fun quotes here that we heard from them as we were talking through the details. We don't even know where everything is. It was built by consultants or people who aren't here anymore. So they viewed it as pretty much a black box of mess that they had in their existing solution. So that was a pretty clear indication that there was going to need to be quite a bit of analysis to understand even what they had before you could consider where to move in the future. No one touches production code because every time they try to improve it or rework it, they end up breaking something else. So there's clearly a lot of intertwined logic, a lot of things that if you work through one change, you're going to potentially break something else. And then lastly, they had a performance problem. So again, it often takes up until 11 a.m. They started at midnight, so that's 11 hours of runtime. And they've spent a fortune on vCPUs, Oracle, all kinds of different things to try to throw infrastructure at the problem. And that is, again, compounded because they don't want to touch the code to try to improve it because they would break it and cause a production outage. So then they therefore try to fix it by adding more infrastructure, which then has large cost implications. As promised, let's take a deeper look at the existing solution that was built on Oracle with Warescape so we can understand, again, the magnitude of the challenge and where and how they were focused when thinking through migrating from the legacy solution to a more modern stack. So looking at the kind of left to right flow of data, we have, of course, the raw system. This was also in Oracle. They then built a copy of that data, a snapshot, based off of their nightly load schedule. It's called their load layer. They then went to stage, which they then used to detect what changed from this version of the data versus the previous version of the data. And then they had a layer around the Data Vault 2.0 methodology called the hub. And this, for those of you who aren't familiar, again, Data Vault 2.0 is a specific way to do change tracking and help with slowly changing dimensions type 2 and a few other ideas. Highly encourage you to look into that. It's an interesting model. But they had the three typical tables, depending on the data set. They'd build at least the hub and then the satellited link appropriately. Then finally, they had their target data warehouse. And so looking at this first few layers, this was actually very well formed, really well architected. Their target data warehouse was really well modeled. And so looking kind of at this layer, it's hard to imagine, how you're able to get to, 5,000 scripts and 500,000 lines of code, especially because when you do some analysis and you look at how many application tables, how many source tables were actually being referenced, it was less than 50. And so, again, just doing some basic math, it's hard to imagine how you can get to 5,000 scripts. What we learned is that despite the well-formed architecture at this layer, where things fell apart is when they were looking to implement custom business logic, do some surrogate key creation and remodeling in order to support the data warehouse. Because the data warehouse wasn't just a straight pass-through. They had some interpretations of the data, some measures, metrics, and attributes that were developed, customized to their business based off of, I'm sure, some requests from the business or from some executives. And those solutions were non-trivial. They required some relatively complex transformation. However, not really at the scale that you'd expect to get to such a large code base. And this follows a pattern we've seen many times where, going back to some of those quotes, they really didn't want to touch things that were already built. And so every time there was a new use case, they would develop a new set of packages, a new set of stages, a new set of queries, and implement those and the pipelines to support those separately from the existing solution. And so again, as you can imagine, over a couple hundred or a couple thousand requests over the course of a decade, the proliferation of many different stages, many different packages, many different queries, and the orchestration around all of those became extremely complex. And so this was, again, a very common pattern, whether you're talking about a medallion architecture or a data vault architecture. This section here, this kind of key business logic or custom stage design, whether it's in the silver layer or in between the silver layer and the gold layer medallion, or whether it lives between your data vault and your target data model in the data vault methodology, this is oftentimes where teams really struggle to again, produce well-formed code and eliminate code duplication and design a well-formed architecture. So as expected, this is kind of the key focus area. This is where a lot of the mess was. And so we're going to now take a look at their initial approach to solving this problem. And then we're going to look at how DataForge was able to rethink about and reset their baseline around this solution and simplify the overall architecture. So unfortunately, the customer did not decide to use DataForge on their first attempt at moving off of this legacy solution to a more modern data stack. And their initial approach was a combination of Fivetran, Coalesce, and Snowflake for their stack. They specifically found a professional services firm who had a code migration accelerator to help them move from these thousands of scripts generated by Warescape to a technology called Coalesce, which again has a similar paradigm but more modern solution to help them again move off of Oracle to Snowflake and get on a more modern data stack. The accelerator was specifically focused on taking these scripts and building them into Coalesce, Node, or stages without modification. Basically a lift and shift methodology. Hey, kind of similar approach to what, again, the customer was talking about. We don't really know what's in there. We don't really have the time or ability to analyze 5,000 SQL scripts, to understand all the transformations, but we really need to solve this Oracle problem, and we really need to get on a modern data stack. So let's find someone who can help us move over without having to completely redevelop everything that's in there from the ground up. Unfortunately, this outcome was, it didn't work, is the really long short there. The 5+ consultants spent over 9 months, well over $500,000 spent to try and achieve this goal of this lift and shift. Unfortunately, in that 9 months, they only got about 60% of the way through. They only got about 1,200 nodes out of the 2,000 developed, which is a staggeringly large number of nodes to build, and very impressive that they actually got that much done. But unfortunately, it didn't meet the business needs. It didn't meet the goals of what they were trying to do with this. So they ended up abandoning the project. Customer team who made this decision and hired the consulting firm was fired. And the offshore implementation team, who was outsourced to help this lift and shift methodology, basically cram through those thousands and thousands of lines of code and do quality assurance to make sure, yes, this new code on this new platform is working the same as the old code, was also fired. So a hugely negative impact for everyone involved. Tons of time spent, tons of stress and challenges for everyone, both in the organization and who were trying to help this organization. And it really was the worst possible outcome because they had also partially moved some of their Oracle scripts and their solution to this new platform, meaning they now needed to run the partial new platform and their partial old platform, which really compounded the overall operational costs, which was one of the drivers of the original project. So a really unfortunate outcome for them to take this approach and to try and migrate to this stack. There's nothing wrong with the stack they were trying to go forward with. However, the way that they tried to approach it, as well as, again, some of the technologies they were leveraging to organize these scripts, was a really challenging approach for them to take. Just to drive home the challenge that they faced and why this project failed and why, even with a lot of good intentions and a lot of smart people, they were unable to succeed with the approach and the structures that they were working with. Here's a visual representation of the table lineage for one of the dimensions. In this case, it's this dim org. Dim org consists of 6 columns that are useful to the business and 2 system columns. Look, this visual diagram, it shows the table lineage of every script and every package that is used to power dim org. And if you trace it back, you can see that it's massively intertwined with a lot of other packages, a lot of other scripts, a lot of other SQL that is being leveraged, across the different platforms and yet across the different target tables in the solution. And you can see there's a ton of raw tables, or I should say incoming tables, that are intertwined into all of these scripts. What was interesting is looking at the column level analysis, and if you trace each one of these business columns back to their source table, we found that through all of these packages, through all of this code, there was actually only one transformation done against the raw data to produce these target 6 columns. And it was this very simple case statement to generate dim org. And what was even more amazing is the actual data for this dimension only came from one source table. So it was one source table with one column transformation that ultimately somehow became intertwined with a large portion of the overall platform packages, and scripts. So again, you get this kind of monolithic code base where every single entity, whether it is useful for it to be or not, is intertwined with every other entity or every other target column. And this creates a huge problem for maintenance, a huge problem for expanding the code base over time, but is super typical or highly common in legacy solutions that were developed over the course of many years, and as people added to that logic over time. So now that we have all the bad stuff out of the way, the failed project, the crazy complexity of the solution, let's now look towards how DataForge was able to help simplify the complex and make everything more straightforward and scalable for the future. So instead of looking at the thousands of lines of scripts and how to move those scripts over, we took the traditional DataForge approach, which is looking at the target columns and exactly what they mean to the business, and then column by column, working backwards to their sources, to their source tables, to understand the transformations required to populate those target columns. Removing all the different kind of intermediary transformations and stages you need, just thinking column by column. One of the things we noticed that was adding a lot of complexity to that business logic layer was actually the creation of surrogate keys. And we looked at all the typical reasons businesses leverage surrogate keys or build surrogate keys within a star schema, and found that the organization wasn't leveraging any of those benefits. And in fact, there were natural keys that existed for all of the different dimensions that would work just as well. So that was a pretty big scope change, but again, when we talked through with the client and they understood why removing those would reduce a lot of the complexity, so we moved forward with that approach. Just real quick, today DataForge supports Databricks. We do have a roadmap for Snowflake full support. However, in this case, they did want their target tables to be in Snowflake. However, DataForge today for the transformation side supports Databricks. We do have a very deep integration with Snowflake for that output layer, for that final target layer. So we were able to fully support their need for the business to engage with Snowflake and for the reports to run off of Snowflake. However, the transformation processing, all of the business logic that is implemented in the pipelines, that was executing on Databricks job clusters, which are very cost-effective infrastructure. Final outcome is pretty dramatic. So rather than 7 months and not completing the project, an internal team was able to complete the project within about 3 weeks. They did spend around 2 weeks verifying all the data, reconciling it, doing hashes and aggregates to do QA to make sure that every column and every table was identical between the old and new solution. But when you look at the metrics, again, it's a pretty staggering difference between the legacy solution and the solution built in DataForge. So the legacy solution had, again, almost 500,000 lines of code. The DataForge solution, most of those lines of code were automated or generated, and it's only about 1,700 lines of code. So almost a 300 times reduction in the number of lines of code. And the way DataForge is organized is we have an object model, which again, I'll put a link into that other video to review the object model right here. But there it was around only 270 objects, 25 sources, 31 outputs, 36 rules, and 178 mappings. So a huge reduction in the number of things that the team needs to manage or consider and operate when something breaks, how to go fix it, where it is now dramatically reduced. And the way those objects are structured is it's no longer a monolith. It's no longer all fully intertwined. Changing one of those objects is now no longer going to affect everything else in the system. From an infrastructure perspective, it was a huge lift. Again, DataForge, one of our offerings, part of our offering is making sure the underlying infrastructure is running extremely efficient in an optimized fashion. And so the new stack was, over $200,000 a year cheaper than the legacy Oracle infrastructure. Again, that was one of the goals of the project. And then comparing it to the Fivetran and Coalesce and Snowflake, full Snowflake stack, it was around $100,000 less per year. So even though we have two different vendors involved now between Databricks and Snowflake, which is from a market perspective unique, most people try to just pick one or the other, it actually was considerably cheaper than just using Snowflake in this case. And then on the people side, again, this is more about how these full-time resources can be used for future aspirations. Again, they had a lot of needs for adding additional data sources, building machine learning models, to keep the beast alive, if you will. Went from a team of 3, and actually it was 5 total when they had both running, full-time employees, to 3 to now 1. They just needed one person to continue to manage, monitor, tweak, and update the DataForge solution to make sure that day to day it's rock solid and that there's 0 production outages along the way. So pretty dramatic results. Take a deeper dive on some of the details coming up, but this just shows how taking a differentiated approach using DataForge can completely change the game from using the more traditional stage-based design and architecture. This is a pretty dramatic visual representation. Again, we picked this one out because it was particularly offensive, given the legacy versus future state, and how the original plan to lift and shift, regardless of technology, was again the most common approach for teams to take. However, in this case, severely misguided. So just looking at the lineage at the table level of what the legacy solution was in Warescape versus what DataForge looks like. On the left here, this is from our Lineage feature within the product. Very simple 3-step tables to go from the raw data in this PC organization table to the dim org. There was a couple, that one transformation was in there that I mentioned with the case statement. And again, comparing it to this visual we already had, where there are hundreds of tables involved and thousands of packages and SQL scripts in order to support these transformations along the way. Looking at the entire warehouse, so again, moving from just that one dimension, which if you can imagine, each one of these dimension tables, and especially the fact table was even more complex, has their own visual that looks like this or worse for that specific table within the legacy solution. Here is the fully combined solution of the entire data warehouse. Again, those 15 tables that support the data warehouse in DataForge. So again, DataForge is of course all focused about building pipelines, building technologies. But one of our key differentiators and the most important differentiator is actually how developers are forced to think and how developers are forced to build solutions in DataForge to dramatically simplify the overall architecture and the overall pipeline structures of the platform. So when you build in DataForge, you will always have a solution that is going to be dramatically simplified versus other technologies when you look at the table level lineage, due to the way developers are highly encouraged or sometimes enforced to fit within the framework. So again, this is many orders of magnitude more simple than the legacy solution. And if you can think about, again, when we mentioned the Coalesce and Fivetrain and Snowflake solution, they had 1,200 nodes developed before they decided to stop the project. And a node in Coalesce would be equally represented by one of these boxes here. So again, if you think about the simplicity of this solution and how taking an approach, even a well-informed approach with Coalesce, was 1,200 of these individual boxes. It shows how taking the DataForge approach and the framework can really help organizations rethink the way that their pipelines are organized and dramatically simplify their code bases. As a final overview, and just to really drive the point home, again, one thing that's not available in many other solutions is column level lineage. So this is not column table lineage where you can see kind of a column passing through table calculations. We have something called column to column lineage, which again is foundational to the way you develop and build in DataForge. And the reason it's not available in other platforms is because there's more flexibility in how developers build their code, such that a visual like this actually is impossible logically within their code base. And so just kind of highlighting that even drilling down to the column level, where you're seeing every single transformation, every single mapping, every single object that's in the DataForge system, it still is simpler than that one stage-based complex solution that we showcased for that single dimension dim org. So again, just driving the point home that by leveraging DataForge, And taking a differentiated approach to building pipelines, you end up with a solution that is better in pretty much every way. And of course, even though this solution is much simpler, the most important part about DataForge is being able to add more columns, more reports, more target systems, more capabilities to the platform over time. So although this looks somewhat complex, it's actually very easy to then augment and add additional logic to this solution without falling into the same trap of a rat's nest of stages and complexity that we saw proliferate in the original solution developed on Warescape. And again, this isn't something specific to Warescape. This is the same in tools like Coalesce or Matillion, even tools like DBT and writing Python code in Spark. It's fundamental to the actual way those solutions build pipelines. DataForge does stuff differently and structures pipelines differently, which allows for this differentiated, simplified, and scalable approach to data platform development. Wrapping things up, we want to then again go to the final outcome. This was a huge success for the customer. They were able to get done in about a month and a half what they had been trying to work on for well over a year. When you think about kicking off the implementation project, the design, the architecture, the tool selection, everything that goes into this large conversion, they were able to get the equivalent result and an improved result in less than 2 months, again about 5 weeks. They're able to achieve all their goals supporting the ML and AI. They moved to a hyper-modern cloud infrastructure. They were able to reduce their operational overhead by having less people needed to maintain the platform. And they're set up for success to add more logic, more data, more solutions to the platform over time. So that's it. We really looked at everything at a high level today. We really brushed over all the details and we didn't go through any examples of what the new solution looks like in DataForge. In a follow-on video, which will be coming shortly, we're going to walk through how we were able to develop the replacement columns in DataForge and what that process looks like, navigating through the thousands of lines of code that were in the legacy solution, and what that looks like and how they were able to achieve it so quickly despite the level of complexity, despite the thousands and hundreds of thousands of lines of code. Thankfully, the developers did not have to look at 500,000 lines of code in order to rebuild this solution. There's a really straightforward approach, again, utilizing the DataForge framework to pick out exactly what's needed, develop it, and quality assure it to do these types of conversions, leveraging our platform. That's it for today. Please make sure you like, subscribe, share us on social media. Again, we're really excited about this use case and this case study. And please reach out for comments and questions. Have a great day.